Okay, what I want to do is do this problem as it's written in the notes, by the way. It's neatly presented, and I want to encourage this to neatly present your work. I know a lot of times when I'm writing at the whiteboard, it's kind of all over the place, which is typically the way I set a problem up. I write it all over the place, and then I try to summarize it in a neat format. All right, and what I want to claim over here is, kind of looking at the problem, these things here are called the major fraction bar. These guys over here, let's write this over here, these are minor fractions. All right, so what we normally do, it doesn't always work, but it's a nice thing to simplify a problem, is we like to build away the complex fraction by multiplying by the minor LCD. The minor LCD is the LCD of the minor fractions. Well, if you look at this problem over here, the minor LCD in both cases, this is the minor LCD in both cases is 6xy. So what I do is I build it away. And so what I do is I multiply the top and the bottom by their minor LCD. What's nice about this is that when I multiply the top by the minor LCD, I get something pretty simple. And why is that? I'm distributing the 6xy across those two terms. There's cancellations. They're conditional, but they're cancellations. You would get 3y plus 2x if I did this distribution here. All right, let's do the next one. If I did this distribution over here, what would I get? I would get 2y minus 3x. All right? So that's done. So then someone says, what are you going to do at the bottom? I'm not going to multiply it. What I'm going to do at the bottom is just simply do a factorization of the bottom. And it's partially factored. What does that mean? Well, looking at it, I already have a 6xy there because I multiplied by it. And then I factor this thing, 4x squared minus 9y squared. Well, that's a difference of perfect squares. You get that? Same thing over here. I'm multiplying the bottom by 6xy. And then I factor this, which is a difference of perfect squares. And what's that? 3x minus 2y, 3x plus 2y. All right? Now, I'm going to get my eraser out. And again, I'm pointing at, I'm getting step by step through the key. And I want to tell you where I am now. I'm here. And I'm looking at these two denominators. Let me outline them for you. And what do I notice? Well, let's take a look. I get 6xy in both of them as factors. I get 2x. No, they're not the same denominator. So what I'm going to do next is, I don't want to build that. It would be crazy. It would be just too much work. I'm going to look at the top now and see if there's something there I can do. Well, what I notice over here, whoops. I notice if I just factor the tops, I did it again. If I just factor the tops, what do I notice? That the factor on top, I just factorized it, 3y plus 2x would cancel. I know the factor over here, 2y minus 3x, well, it doesn't cancel, does it? What is it? It's an opposite, so it would cancel to minus 1. Right? So I'm going to write that down now. So the next step is, I got 1 here. Let me get my highlighter out. And on the bottom, I'd get 6x, 2x minus 3y. Now remember, we got this cancellation, so plus and minus 1. I was going to say minus 1. What's left on bottom? 6xy, 3x plus 2y. All right? Now, I'm at this stage here. I'm getting to this line, right? Let me erase this over here. I'm here now. What I notice about this over here is that, they both have a factor of 6xy in it, but now they got to be built. Right? And why did that have to be built? They really have a different denominator. But it looks like the LCD here is pretty simple. And what's the LCD going to be? I'll write this down the side for you. The LCD is going to be 6xy, 2x minus 3y, and 3x plus 2y. All right? We're at this line here. All right? So what do? I actually write the builders down for you. So this guy's going to be 3x plus 2y, and this guy's going to be 2x minus 3y. All right, what do I do now? The denominators are equal. They both have a factor of 6, a factor of x, a factor of y. a factor of 2x minus 3y, and a factor of 3x plus 2y. And now I'm really left with the numerator algebra. And let me write it aside for you. I would see 3x plus 2y. That's coming from here. And let's do this one over here, but realize we're subtracting it. So it's going to be minus 2x. And minus 3y is plus 3y. What would that give us? That would give us x plus 5y, which we're seeing right over here. And we're here. We're done. All right? So again, someone said, I want to do it differently. You can. Here's the deal, though. At the end of it, that's the answer you're going to be staring at. Thank you.